Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. And of course, if you like my videos, if they are important to your studies, please don't forget to subscribe. This problem is lengthy because I present all the methods, and it is also a test of your understanding and expertise on the different basic method, the five basic methods, considering an indeterminate uh, beam, and we make it determinate by the principle on uh, method of consistent deformations, wherein we remove some constraints to make it determinate and compute for the corresponding reflections at the supports. Then we apply the forces or reactions at the supports to have also deflection, and the net deflection should be equal to 0 because the supports are unyielding in this situation. So the five basic methods, we have double integration, area moment, conjugate beam, and we have energy methods, the virtual work and the Castigliano's second theorem. And we will solve this by the method of least work, which is more direct than these five basic methods. So this is the given figure, and the beam is indeterminate to the second degree. So we have two redundants here. Let's make the redundants B and C. So for the first method, double integration, let's have all these reactions as unknowns, and we'll have that sectioning X, call that RA, R sub B, R sub C, then R sub D. Then we establish the differential equation of the elastic curve by extending the load, so that we will have an equation for the entire beam, and we counter it by the same loading. So AIY double prime is equal to RA times X plus R sub B times quantity X minus 6 plus R sub C times quantity X minus 10, then plus this load here, 30 times X minus 6 times X minus 6 over 2, so 15 X minus 6 square, minus 30 times X over 2, that's why you have minus 15X square, then minus 36 times quantity X minus 8, then plus 90 times quantity X minus 13 raised to 0, because this couple acts at X equals 13, and this is also constant. That's the technique from our previous problems and solutions. So integrating once, EIY prime equals RA X square over 2 plus RB quantity X minus 6 square over 2 plus R sub C quantity X minus 10 square over 2 plus 5X minus 6 cube minus 5X cube minus 18X minus 8 square plus 90X minus 13 to the 1 plus C sub 1. There is slope at A, but there is no C sub 2 because it is a support. Then unyielding support. Then EIY equals RAX cube over 6 plus RB quantity X minus 6 cube over 6 plus R sub C X minus 10 cube over 6 plus 5 fourths or 1.25 X minus 6 to the 4th minus 5 fourths X to the 4th minus 6X minus 8 cube plus 45X minus 13 square plus C sub 1X. There's no C sub 2 as I said. So let's have the boundary conditions. First, moment at D is 0. So 0 in this equation, RA times 15 when X is 15 plus RB times 15 minus 6 and 9 plus RC 15 minus 10, so 5 RC, then plus 15 times quantity 15 minus 6, so 15 times 9 square minus 15 times 16 square minus 36 times 7, 15 minus 87, and plus 90, 15 minus 13, 2 to the 0 is 1, so plus 90. This equation is the same as summing moments about d equals 0. So simplifying, 15RA plus 9RB plus 5R sub C equals 2322. Call that equation 1. Then x is 6, y is 0 into this equation. So 0 equals RA 6 cube over 6. Then this is 0, 0, then 0 minus 5 fourths 6 to the 4th. Then everything is neglected, ignored, then except C sub 1 times 6. Simplifying this equation, we have 36RA plus 6C sub 1 equals 1620. Call this equation 2. When x is 10, y is 0, so 0 equals RA 10 cube over 6 plus RB 4 cube over 6. Then plus 5 fourths times 4 to the 4th minus 5 fourths 10 to the 4th minus 6 times 2 cube plus C sub 1 times 10. Simplifying, 500 over 3 RA plus 32 over 3 R sub B plus 10 C sub 1 equals 12228. Call that equation 3. Then when x is 15, y is 0 into this equation. So 0 equals RA 15 cube over 6 plus RB 9 cube over 6 plus RC 5 cube over 6 plus 5 fourths 9 to the 4th minus 5 fourths 15 to the 4th minus 6 times 7 cube plus 45 times 2 square, then plus C sub 1 times 15. So simplifying this equation, we have 562.5 RA plus 121.5 RB plus 125 over 6 RC plus 15 C sub 1 equals 56958. Equation 4. Then if you have a calculator that can solve 4 simultaneous equations allowed by your professor or allowed in the board exam, then you can do it. But I assume that my calculator is only capable of solving 3 simultaneous equations. So from this equation 2 here, let's express C sub 1 in terms of RA. So C sub 1 equals negative 270, 1620 over 6, then minus 36 over 6, and minus 6 RA. Substitute this into equations involving C sub 1 in equation 3 and equation 4. So into equation 3 first, 500 over 3 RA plus 32 over 3 RB plus 10 times quantity 270 minus 6 RA equals 122228. So simplifying, 320 over 3 RA plus 32 over 3 RB equals 9528. Call this equation 3A. Then into equation 4, C sub 1, 562.5 RA plus 125.5 RB plus 125 over 6 RC plus 15 times quantity 270 minus 6 RA equals 56958. Simplifying, we have 472.5 RA plus 121.5 RB plus 125 over 6 RC equals 52908, equation 4A. So solving equations 1, 3A, and 4A simultaneously, we can now solve RA, RB, and R sub C. So R sub A is 73.953 kilonewtons. R sub B is equal to 153.715 kilonewtons. R sub C is equal to negative 34.148 kilonewtons. Then we may sum up moment about A or summation forces Y to solve for RD. So this is summation forces Y. RA plus RB plus RC plus RD equals 30 times 6 plus 36. So R sub D is equal to 22.480 kilonewtons. So that's it for this double integration. We now proceed to the 5 basic methods. First, by double integration, by removing redundants B and C to deflect the beam to become a determinate beam, so we can solve deflections at B and at C. Then we apply forces RB and RC to deflect it upward by the same method, double integration, and the rest of these 5 methods. So here is the first basic method by double integration. Same problem. I now remove supports at B and C so that this will deflect. So summation moment about D equals 0. This would be the reaction AY, and at D it is 61.2. So reaction at A times 15 equal plus 90 equals 30 times 6 times 12 plus 36 times 7. So that is statics, and you can show that these are the reactions. And that's a deflected shape. We extend because we apply double integration and counter the same. So that's the section there, X. Then EI Y double prime equals 154.8x plus 15 times x minus 6 square minus 15 times x square minus 36 times x minus 8 plus 90 times x minus 13 to the 0, just like before. At this time, the beam becomes determinate. EIY prime equals 77.4x squared plus 5x minus 6 cubed minus 5x cubed minus 18x minus 8 squared plus 90x minus 13 raised to 1 plus C sub 3. So I call this C sub 3. It's different from C sub 1 before because that was solved by double integration, and we made the beam indeterminate. This time it is determinate. Then there is no C sub 4 because A is the support. EIY equals 25.8x cubed plus 5 fourths quantity x minus 6 to the fourth minus 5 fourths x to the fourth minus 6x minus 8 cubed plus 45x minus 13 square plus C sub 3x. There's no C sub 4 as mentioned. Then we have boundary conditions to solve for C sub 3 when x is 15, y is 0. So 0 equals 25.8, 15 cubed plus 5 fourths 9 to the fourth minus 5 fourths 15 to the fourth minus 6, 7 cubed plus 45, 2 square plus C sub 3 times 15. So solving for C sub 3 from this equation, C sub 3 equals negative 2007.8. So when x is 6, we can now solve deflection at B or YB or delta B. IYB equals 25.86 cubed. This is 0 minus 5 fourths 6 to the fourth. Ignore, then plus C sub t negative 2007.8 times 6. So YB or delta B is equal to negative 8094 over EI. Then when x is 10, we can solve y sub c or delta c. Y sub c equals 25.810 cubed plus 5 fourths 4 to the fourth minus 5 fourths 10 to the fourth minus 6 times 2 cubed plus c sub d negative 2007.8 times 10. So y sub c is equal to negative 6506 over EI. So these are the deflections at B and C if supports B and C are removed. Now we apply RB and R sub C and apply double integration method again. Then let's solve for RA. summation moment D equals 0. So this will be the value of RA going down. RA times 15 equals RB times 9 plus RC times 5. So 9 divided by 15 is 0.6. That's why you have 0.6 RB. Then 5 divided by 15 is 1/3. So plus RC over 3. So let's call that X. Will not just involve RD. So by double integration, that's a deflected shape. So EIY double prime equals negative quantity 0.6 RB plus RC over 3 times X plus RB times quantity X minus 6 plus RC times quantity X minus 10. Integrating once, EIY prime equals negative 0.3 RB X squared minus RC X squared over 6, then plus RB quantity X minus 6 squared over 2 plus RC X minus 10 squared over 2 plus C sub 5. Integrating again, EIY equals negative 0.1 X RB X cube minus RC X cube over 18 plus RB quantity X minus 6 cube over 6 plus RC quantity X minus 10 cube over 6 plus C sub 5X. There's no C sub 6 again because when X is 0, Y is 0. Then let's have the boundary condition to solve for C sub 5. When X is 15, so 0 equals negative 0.1 RB 15 cube minus RC 15 cube over 18, then plus RB 9 cube over 6 plus RC 5 cube over 6 plus C sub 5 times 15. Combining like terms and divided by 15, C sub 5 equals 14.4 RB plus 1000 over 9 R sub C. So that's the value of C sub 5. We can now compute YB or delta B for this situation. So EIYB due to reaction is equal to negative 0.1 RB times 6 cube into this equation when X is 6 minus RC 6 cube over 18, that is 0, that is ignored, then plus C sub 5 which is 14.4 RB plus 1000 over 9 RC which is this, then times X which is X is 6. So in terms of reactions, EIYBR due to reaction, deflection at B due to reaction is 64.8 RB plus 164 RC over 3. Adding YB equals 0, so the first equation is 64.8 RB plus 164 over 3 RC equals 1894. So the equation supposedly is YBR plus Y sub B equals 0. There's no net deflection at B. So when we transpose this to the right, it becomes positive. So call that equation A. When X is 10, then we can solve EIYCR due to reaction into this equation. So negative 0.1 RB times 10 cube minus RC 10 cube over 18, then plus RB 4 cube over 6, then plus C sub 5 which is quantity 14.4 RB plus 1000 over 9 RC times 10. Combining like terms, then we can solve EIYCR. So EIYCR equals 164 over 3 RB plus 500 over 9 R sub C. Then plus EIYCR or YCR plus Y sub C must be 0. So since this is negative, transposed to the right, it becomes positive. So the second equation is 164 over 3 RB plus 5000 over 9 R sub C equals 6506. Equation B. Solving these two equations simultaneously. So RB equals 153.715 kilonewtons as before. R sub C equals negative 34.148 kilonewtons as before. Then you sum up moment about D so that you can solve for RA, RB, and RC have been found. So that is already statics, and we solved that already in the first method. So I'll just put directly the answers without further statics. What is important is we have found the two values the same as before. And R sub D is also by statics also summation versus Y after solving this whole reaction, vertical reaction. So RD is 22.48. So that's it for the first basic method by double integration. So let's proceed to the second method, basic method. This is area moment. So same beam, after we remove the two reaction components, reaction or supports, it becomes simply supported. And this was the reactions. This is the reaction at A, vertical reaction at D. Then let's have the moment diagram by parts. Let's make B as our moment center. So we have 154.8 times 6, 928.8. Due to this loading, due to this reaction, 61.2 times 9 is 550.8. Due to this loading, second degree, 30 times 6 times 3, second degree is 540 over EI. Just make EI 1, it is constant. Then due to this 90 kilonewton load, 90, and due to this load 36 times 2 is 72 over EI, or 72. So this is the moment diagram by parts. That's the deflected shape. So let's solve for this deviation of D relative to A so that we can solve that slope. So EI deviation of D relative to A is moment of areas about D. So we begin with this area, 1/2 or 0.5 of 6 times 9 to 8.8. 1/3 of 6 is 2, 2 plus 9 is 11. Then this is 5, 9, 2/3 of 9 is 6, the moment arm. So plus 0.5 of 9 times 550.8 times 6. 2/3 of 9 is 6. Its distance here, centroid, distance of its centroid from here. Then minus this area 1/3 of 6 times 540. Then this distance is 6 over 4, 6 over degree plus 2, or 1.5, then plus 9. For the triangle, minus 0.5 of 2 times 72, 2/3 of 2 is 4/3, then plus 7, because that is 7. 2/3 of 2 is 4/3, then plus 7. Then minus this rectangle, area of this rectangle moment is 7 times 90, moment arm is 7 over 2, 3.5 plus 2, so 5.5. So minus 7 times 90 times 5.5. So from there we can solve division of D relative to A, and it is positive because D is above the reference tangent at A. But the slope theta A is negative because it is the tangent rotates clockwise. Clockwise rotation is negative. Counterclockwise is positive. So theta A is equal to negative of 30,107 over 15 divided by 15. So theta A is equal to negative 2007.8 over EI, which is supposedly C sub 1 from deflection method, or C sub 5. I forgot the designation, over EI. but this is familiar. So we can next evaluate division of B relative to the tangent at A, that one. And this one, division of C relative to the tangent at A. So let's evaluate first. Division of B relative to tangent at A equals moment of areas between A and B with respect to B. So there are only two areas, these two areas here. So equals 1/2 or 0.5 of 6 times 9 to 8.8 times 2. 1/3 of 6 is 2. And minus 1/3 of 6 times 540 times 1.5. Remember, this is 6 over 4 or 1.5. So division of B relative to tangent at A is positive because B on the elastic curve is above the reference tangent, 3952.8. So from there, we can solve delta B or YB, which is, this is 6 times theta A, right triangle. Opposite is 6 times theta A. Let's just make theta A positive, then minus division of B relative to A. The deflection is negative. So that's delta B. So delta B is negative of quantity 6 times theta A, which is also made positive, minus division of B relative to A, which is 3952.8. So delta B is negative 8094 over EI, just like before. Then let's solve for this division. But before that, the value here is 61.2 times 5. That's 306 over EI supposedly. And let's divide this trapezoid into two triangles as shown. So this is division of C relative to the tangent at A. And it is expected positive also. We consider the areas between A and C. We sum up moments of these areas about C. So EI division of C relative to A equals, beginning with this positive area, 0.5 of 6 times 9 to 8.8. 2 plus 4 is 6, or 2 plus 4, the moment arm, plus this bigger triangle, 0.5 of 4 times 550.8. 2/3 of 4 is 8/3. So 2/3 of 4 is 8/3, plus this area, 0.5 of 4 times 306 times 1/3 of 4, so 4/3. And minus this area, 1/3 of 6 times 540, 1.5 plus 4, moment arm. Plus this triangle, 1/2 or 0.5 of 2 times 72. 2/3 of 2 is 4/3 plus 2, so 4/3 plus 2. Finally, for this area here, up to here only. So 4 times 90 minus 4 times 90 times 2. Just consider this area. So 4 times 90 times 2. Simplifying, EI division of C relative to A equals 13572. Then this is the deflection at C. EI delta C equals the negative of 10, because that is 10 theta A, and minus division of C relative to A, you will get that. But this is treated, this is negative because it is below the x-axis. And we made the theta A positive, so that this is the entire value, 10 theta A, and minus division of C relative to A. So that is left, and we make it negative. So delta C equals negative 6506 over EI, just like Y sub C. So those are the deflection. Now we apply the reactions, and it will deflect upward, computing delta B prime and delta C prime, which are equal respectively to delta B and delta C numerically. So let's solve for RA. Summation moment D equals 0. So RA times 15 equals RB times 9 plus RC times 5. So RA should be downward. So RA equals 0.6 of RB plus RC over 3. Then let's have the moment diagram by parts. Let's make D as our moment center. So that's why we have here 0.6 quantity 0.6 RB plus RC over 3 times 15. So this becomes 9 times 6 first, times 6. So quantity 0.6 RB plus RC over 3 times 6 is 3.6 RB plus 2 RC. Next times 10, so 6 RB here plus 10 thirds R sub C. While here times 15, so 9 RB plus 5 R sub C. Then moment of RB is 9 RB here, triangle, over EI. So RB times 4, so 4 RB, but here RB times 9, so 9 RB. Then RC times 5, so 5 R sub C. Then let's compute the EI deviation of D relative to A prime. So moment of areas between A and D. So this entire area here, respect to D. Let's begin with the positive one. 1/2 of 9 times 9 RB times 1/3 of 9 is 3, plus 1/2 of 5 times 5 RC times 5 thirds. Then minus 1/2 of 15 times quantity 9 RB plus 5 R sub C times 5. 1/3 of 15 is 5. Combining like terms, and we have EI division of D relative to A prime equals negative 216 RB minus 5000 RC over 3. So we can now solve theta A, which is expected positive, although that's negative because the tangent rotates counterclockwise. So theta A is opposite over 15, so we just divide this by 15. So EI theta A prime equals, theta A prime rather, is positive 216 RB plus 5000 over 3 RC over 15. So EI theta A prime equals 14.4 RB plus 1000 RC over 9. So be reminded by that. And let's solve for division of B relative to A prime and division of C relative to A prime on the next slide. This was the result. So EI theta A prime was 14.4 RB plus 100 RC over 9. So let's evaluate EI division of B relative to A prime, and that's the moment of area between A and B only. So 1/2 of 6 times quantity 3.6 RB plus 2 RC times 2. 1/3 of 6 is 2. Simplifying, EI division of B relative to A prime equals negative 21.6 RB minus 12 R sub C. Then we can now solve delta B prime. It is equal to 6 theta A, where theta A is treated positive. As long as this is positive, then minus division of B relative to A prime. Or we just add because this is already negative. So 6 times theta A prime, then minus or plus or minus the positive value of this. So minus 21.6 RB minus 12 R sub C. This division of B relative to A prime. So combining like terms, EI delta B prime equals 64.8 RB plus 164 over 3 R sub C. Then plus the deflection at B, which was negative, equals 0. So we can set up the same equation, 64.8 RB plus 164 over 3 RC equals 8094, or this was negative 8094. Deflection at B. So adding with the positive, it becomes 0. So that's why we transpose this to the right. So 8094. Call that equation A. Then let's solve for EI division of C relative to A prime. We consider these areas here with respect to C. So 1/2 of 4 times 4 RB times 1/3 of 4 4/3, and minus this area, minus 1/2 of 10 times quantity 6 RB plus 10 RC over 3. 1/3 of 10 is 10/3 moment arm. Combining like terms, EI deviation of C relative to A prime equals negative 268 RB over 3 minus 5000 RC over 9. So that delta C, which is positive, is absolute value negative of absolute value of 10 theta A prime, and minus or add this. We just add this because they are already made negative. They are negative. The terms are negative. So 10 times theta A prime, then minus 268 over 3 RB minus 500 RC over 9. So EI delta C prime is equal to 164 over 3 RB plus 500 over 9 RC. Then equals the deflection at C when the supports are removed. I think it was 6,000 something. 6,506, yes. Equation B, so same equations formulated from double integration, so the answers will be the same. So RB equals 153.715, R sub C is negative 34.148 kilonewtons, so solve for RA by statics. Not this one, because this is the reaction due to RB and R sub C. And RD by statics was 22.480 kilonewtons. So that's it for this method, area moment. The next basic method is by conjugate beam method. So we again remove supports at B and C. Then we made B as the moment center. Then the supports would be the same, pin here and roller there. So call that theta A. Then we have theta B later and deflection at B later for our analysis. But let's solve for theta A first by summing up moments about D equals 0. Call that theta D. So theta A times 15 plus this area, 0.5 of 6 times 9 to 8.8, 2 plus 9 is 11, plus this big triangle, 0.5 of 9 times 50.8, 2/3 of 9 is 6, minus this spandrel, 1/3 of 6 times 540, moment arm is 1.5 plus 9 is 10.5, minus this triangle, 1/2 of 2 times 72 times 4/3 plus 7. 2/3 of 2 is 4/3, then plus 7. Then minus the area of rectangle, 7 times 90, 3.5 plus 2, 5.5. So 7 times 90 times 5.5 equals 0. So we can now solve theta A. It is equal to negative 2007.8 over EI, which is the same as before. So delta B is negative 2000.8 times 6, summation considering A, B, and we sum up moment about B equals 0. So this is counterclockwise, so equals clockwise moment minus counterclockwise moment. So delta B equals theta A, which is negative 2007.8 times 6, then plus moment of this area, 0.5 times 6 times 9 to 8.8 times 2, minus the moment of this area, 1/3 of 6 times 540 times 6 over 4, or 1.5. So delta B is equal to negative 8094 over EI, just like before. Then considering A to C, so we have theta C positive and delta C counterclockwise positive as our assumption. So summation moment about this point equals 0. So delta C equals theta A, negative 2007.8 times 10 plus the moment of this area, 0.5 of 6 times 928.8. 2 plus 4 is 6 plus moment of this area, 0.5 of 4 times 550.8 times 2/3 of 4, 8/3 plus moment of this triangle, 0.5 of 4 times 306, 1/3 of 4 is 4/3, then minus moment of this spandrel, 1/3 of 6 times 540 times 1.5 plus 4, so 5.5, 6 over 4, 1.5 plus 4, so 5.5, minus moment of this triangle, 0.5 of 2 times 72, 2/3 of 2 is 4/3 plus 2, so 4/3 plus 2 moment are minus moment of this rectangle, 4 times 90 times 2. Just this rectangle, do not include these two areas. It is only between A and C, areas between A and C. So simplifying, delta C is equal to negative 6506 over EI, just like before. Now, due to the reactions, this was the moment diagram by parts from area moment. So we use the same moment center. So the support here is steel pin and here it's ruler. So call this theta A prime and delta D prime or delta D. But that's not important. It's just solve for theta A prime. So summation moment about D equals 0. Theta A prime times 15 plus 0.5 of 9 times 9 RB times 3. 1/3 of 9 is 3 plus 0.5 of 5 times, that is for later purposes, plus 0.5 of 5 times 5 RC times 5/3 and minus 1.5 of 15 times quantity 9 RP plus 5 RC times 5. 1/3 of 15 is 5. So simplifying, combining like terms, theta A prime equals 14.8 RB plus 100 over 9 RC, just like before. Next, we can now solve delta B prime by summing up moment about this point. So delta B prime plus 1/2 or 0.5 of 6 times quantity 3.6 RB plus 2 RC times 2, then equals theta A prime times 6. So combining like terms, delta B prime equals 64.8 RB plus 164 over 3 RC, just like before. Then plus this negative RB plus this delta B equals 0, so the same equation could be formulated. 64.8 RB plus 164 over 3 RC equals 8094, equation A. Then let's have theta B, theta C prime and delta C prime. So delta C prime equals delta C prime plus 1/2 of 10 times quantity 6 RB plus 10 R sub C over 3 times 10/3. We sum up moment here so that the theta B prime is not involved. Then minus or equals theta A prime times 10, then plus 1/2 or 0.5 of 4 times 4 RB times 1/3 of 4, so 4/3. Combining like terms again and simplifying, delta C prime equals 164 over 3 RB plus 500 over 9 RC. just like before. Then plus delta C equals 0. So we form the same equation, 164 over 3 RB plus 500 over 9 RC equals 6506. So these equations are the same as before, then we get the same results. So RB is 153.715 kilonewtons, R sub C is negative 34.148 kilonewtons, and RA equals 73.953 kilonewtons. R sub D is 22.480 kilonewtons. So that's it for conjugate beam method. So let's proceed to the fourth basic method, energy method, which is virtual work method. So remember the reactions, 154.8 and 61.2 kilonewtons. Then for the virtual forces, we apply, let's just assume downward. So downward load. So the reaction here is upward. Reaction times 15 equals 1 times 9. So 9 over 15 is 0.6. Therefore, reaction at D times 15 equals 1 times 6. 6 over 15 is 0.4, 0.4 upward. So let's section the original beam with the supports at B removed. So that's our X. That's next our X on this section. Then in this section, and lastly in this section. So there are 5 sections, 5 segments. So same sectioning as for this virtual forces. So remember, the EI delta equals integral of Mamma Mia, where m is moment at the section due to the actual loads, and small m is moment at the same section due to the virtual forces, then dx over EI. So EI delta B equals integral from 0 to 6 of 154.8x minus 30 times x over 2, or minus 15x squared. That's for big moment. Then in this section, the moment is 0.6 times x dx. Then here in this section here, so plus integral 0 to 2, so that's 0 to 2, of 154.8 times 6 plus x minus 30 times 6 times 3 plus x, moment arm of this load. Then for the virtual forces, 0.6 of 6 plus x minus 1 times x. 0.6 of 6 plus x minus 1 times x dx. Next, in this section here, we have integral 0 to 2 of 61.2x for the big M, and for the small m, 0.4 times x. So integral 0 to of 61.2 times x, then times 0.4 times x dx. In this section, considering forces right, plus integral 0 to 3 of 61.2 times 2 plus x minus 90. Then for small m, 0.4 of quantity 2 plus x only, dx. And finally, in this section, we have integral 0 to 2 of 61.2 times 5 plus x minus 90. Then for the small m, 0.4 times 5 plus x dx. So using your calculator, we can evaluate this integral, 3771.36. This integral is 2333.76. This integral is 65.28. This integral is 576.72. This integral is 1346.88. So combining, delta B is 8094 over EI, which is the same as before, and it is downward because the virtual force is also downward. The deflection at B is in the same direction as this applied unit load, or it is negative. Next, for the application of unit load at C to solve for delta C. Same sectioning, but this time we have 1 at C. So this big M will not change, just the small m. So summation moment D equals 0. Reaction at A times 15 equals 1 times 5. Therefore, this is 1/3. And reaction at D times 15 equals 1 times 10. So this is 2/3. This big M will not change. It will only change in this part. So EI delta C equals integral 0 to 6 of 154.8x minus 15x squared, then 1/3 of x for small m dx. Then plus integral 0 to 2, we copy this big M, then times 1/3 of 6 plus x, the small m, 1/3 of 6 plus x. So we can make this 180. Then in this section, plus integral of 61.2x, then times 2/3 x, 0 to 2. In this section, so we have integral 0 to 3 of 61.22 plus x minus 90, and 2/3 of quantity 2 plus x, the moment arm, a small m. And finally, in this section, integral from 0 to 2 of 61.2 quantity 5 plus x minus 90, then times quantity 2/3 of 5 plus x minus 1x. So minus 1x in this last section. Then using your calculator, the first integral is 2095.2. The second integral is this one, 1691.2. The third integral is 108.8. This integral is 961.2. And this integral is 1649.6. So combining, we can now solve delta C, or yes. So delta C is 6506 over EI in the direction of the applied unit load, which is downward, so that's downward or negative. Then let's have the reactions applied by virtual work. Then RA times 15 summation moment D equals RB times 9 plus RC times 5. So that means RA, which is downward, is 0.6 of RB plus 1/3 of R sub C. Then RD times 15 equals RB times 6 plus RC times 10. So R sub D is 0.4 of RB plus 2/3 of R sub C. So same sectioning, and this is the virtual load applied upward to deflect upward. So this, if that is upward, reaction is downward. Reaction at A times 15 equals 1 times 9. So that's 0.6 downward. This is 0.4 downward. So by statics. So EI delta B prime equals integral 0 to 6 of negative of RA, which is negative 0.6 RB plus RC over 3 times x, then negative 0.6x dx. Then in this section, plus integral 0 to 2 of negative quantity 0.6 RB plus RC over 3 times 6 plus x, then plus RB times x. Then moment in this section is negative 0.6 times 6 plus x plus 1 times x dx. In this section, integral of negative of RD, because this is downward, integral 0 to 2 of negative of quantity 0.4 RB plus 2/3 RC times x, then negative of 0.4x dx. In this section, plus integral 0 to 3 of negative quantity 0.4 RB plus 2/3 RC times 2 plus x. Then for m small m, negative 0.4 of 2 plus x dx. Lastly, in this section, we have integral 0 to 2 of negative quantity 0.4 RB plus 2/3 RC times 5 plus x plus RC times x, then negative 0.4 times quantity 5 plus x dx. So using your calculator, you evaluate separately. So negative 0.6 of x for RB, negative 0.6 of x, then another negative 0.6x, 0 to 6. So for RB. For RC, negative x over 3 times negative 0.6x dx. So using your calculator there, the first value is 25.92 RB plus 14.4 RC. Then in the next integral, negative 0.6 times 6 plus x for RB plus x, then times this dx. For R sub c, negative of quantity 6 plus x over 3 times this same term. So combining using your calculator, 1544 RB over 75 plus 668 over 45 RC. So you have to verify that. For this next integral, we have 32 over 75 RB plus 32 over 45 RC. For this integral, we have 156 over 25 RB plus 52 over 5 RC. And for this last integral, we have 872 over 75 RB plus 644 over 45 RC. So combining, we can now solve for delta B prime, and let's have that on the next slide. We don't have space here. And in terms of RC also. So combining 64.8 RB plus 164 over 3 RC equals 1894. Same equation is formulated. So let's have for delta C in terms of RB and R sub C. So that's 1. Therefore, the reaction here is 1/3, and here it's 2/3 downward. So same sectioning in this section. So EI delta C equals integral 0 to 6 of negative of quantity 0.6 RB, which was RA, plus RC over 3 times x, then times negative 1/3 of x dx. And in this section, integral of quantity negative of 0.6 RB plus RC over 3 times 6 plus x plus RB times x, then times negative 1/3 of 6 plus x. Negative 1/3 of 6 plus x dx. And in this section, integral of negative RD 0 to 2 of negative 0.4 RB plus 2/3 RC times x, then negative 2/3 of x dx. In this section, plus integral 0 to 3 of quantity negative 0.4 of quantity 0.4 RB plus 2/3 RC times 2 plus x, then times negative 2/3 of 2 plus x dx. Lastly, in this section, plus integral 0 to 2 of negative quantity 0.4 RB plus 2/3 RC times 5 plus x plus RC times x, then quantity negative 2/3 of 5 plus x, then plus 1 times x. So again, using your calculator, you integrate for RB separately, for RC separately, and the rest of these terms here, you do the same thing. Combining for the first integral, we have 72 over 5 RB plus 8 RC. For the second integral, we have 668 over 45 RB plus 296 over 27 RC. For the third integral, you have to evaluate this by your own and pause the video to check if these terms or quantities are equal to these answers. Then here we have 52 over 5 RB plus 52 over 3 RC. Then here you have 644 RB over 45 plus 488 over 27. So combining like terms, EI delta C or delta C, then we have this equation, 164 RB plus 5000 over 9 RC, that's for delta C. Then equated to the deflection at C when the supports are removed, 6506 over EI. So we just cancel EI. So since these equations are the same as before, we get the same answers for reactions. So 153.715 for RB, R sub C, negative 34.148. Then by statics, RA is 73.953 and RD is 22.480 kilonewtons. So that's it for the fourth basic method on virtual work method. Next is by Castigliano's second. So this is by Castigliano's second theorem. We apply a force at B to solve for the deflection. So upward, let's assume upward deflection. Then the reaction at A was 154.8, then minus P times 10, P times 9 over 15. So the reaction here would become 154.8 minus 0.6 of P. While the reaction here is 61.2 minus 0.4 of P. It was 61.2 without P, then due to P, it is minus 0.4 P. So that's why we get those reactions in terms of P. And remember that P is just invented. So prior to integration, we set P to 0. And the formula is for deflection is EI deflection equals integral of moment at the section due to the actual load, then the partial derivative of that moment with respect to P dx over EI. So in EI delta B equals integral of quantity 154.8 minus 0.6 P times x minus 15x squared. Then the derivative of this with respect to x is negative 0.6, with respect to P is negative 0.6x dx, which is the same as before after we set P 0. Then plus in this section integral of 0 to 2 of quantity 154.8 minus 0.6 P times 6 plus x minus 30 times 6, 180 times 3 plus x plus P times x, take note. Then partial derivative of this moment equation with respect to P is negative 0.66 plus x. There is P here, plus x. Next in this section, integral of from 0 to 2 of quantity 61.2 minus 0.4 P times x, and the derivative is negative 0.4x dx. In this section, plus integral 0 to 3 of quantity 61.2 minus 0.4 P times 2 plus x minus 90. Derivative is negative 0.4 of 2 plus x with respect to P. Finally, in this section, integral from 0 to 2 of quantity 61.2 minus 0.4 P times 5 plus x minus 90. Then the differential is negative 0.4 of 5 plus x dx. So set P0, evaluate using your calculator. So integral of 154.8x minus 15x squared times negative 0.6x dx. The result is negative 3771.36. Set that to 0, set that to 0. Integrate negative 2333.76. Set this to 0, so integral of 61.2 times x times negative 0.4 x dx is negative 65.28. Set this to 0, and the integral is negative 576.72. Set this to 0, and the integral is negative 1346.88. So combining these values, delta B is negative 8094 over EI. Then deflection at C. So we have the beam P this time is at C. So the reaction here is 154.8 minus, because P times 5 divided by 15 is 1/3. So 154.8 minus 1/3 of P. Then here 61.2 minus 2/3 of P. So by Castigliano's second theorem, EI delta C is equal to integral 0 to 6 of 154.8 minus P over 3 times x minus 15x squared. The derivative of with respect to P is negative x over 3 dx. Then in this section, integral 0 to 2 of quantity integral of 154.8 minus P over 3 times 6 plus x minus 180 times 3 plus x. Then derivative is negative quantity 6 plus x over 3. Derivative with respect to P. Negative 6 plus x over 3. Then in this section here, integral of quantity 61.2 minus 2/3 of P times x, derivative negative 2/3 x dx. Then in this section, integral of from 0 to 3, quantity 61.2 minus 2/3 P, 2 plus x minus 90, derivative negative 2/3 of 2 plus x dx. Finally, in this section, integral of quantity 61.2 minus 2/3 P, 5 plus x minus 90 plus px. Then derivative is negative 2/3 5 plus x, because there is p here. So set p 0, then the value of the integral here is negative 2095.2, just like before. Set this to 0, negative 6091.2, set that to 0, negative 108.8, set that to 0, integral negative 961.2, set this to 0 and this 0, integrate negative 1649.6. So delta C is combining these values in yellows. Delta C equals negative 6506 over EI, just like before. Then due to the reaction on the next slide, Castigliano's, so EI delta B prime, this one is EI partial of U with respect to RB, and it is integral 0 to 6 of, this was RA, negative 0.6 RB plus RC over 3. You can derive that again by summing up moment about D by statics, times x, then partial derivative with respect to RB is negative 0.6 x dx. Then in this section, integral of from 0 to 2 of negative quantity 0.6 RB plus RC over 3 times 6 plus x, then plus RB times x. The derivative with respect to RB is negative 0.66 plus x, then plus x. Then in this section, integral of 0 from 0 to 2 of negative of quantity 0.4 RB plus 2/3 RC times x. Derivative with respect to RB is negative 0.4 x dx. Then in this section, integral from 0 to 3 of negative quantity 0.4 RB plus 2/3 RC times 2 plus x. Derivative with respect to RB is negative 0.4 times 2x, 2 plus x dx. And finally, in this section, integral from 0 to 2 of quantity negative 0.4 RB plus 2/3 of over 3 RC times 5 plus x plus RC times x. Derivative with respect to RB, negative 0.4 of 5 plus x dx. So integrate separately, equate to 0 as equate to delta B prime. Individually for RB first, then for RC. This integral gives us 648 over 25 RB plus 72 over 5 RC. And this integral gives us, evaluate separately for RB and for RC, 1544 RB over 75 plus 668 over 45 RC. In these integrals, evaluate separately. 32 over 75 RB plus 32 over 45 RC. This integral is 156 over 25 RB plus 52 over 5 RC. Then this integral is 872 over 75 RB plus 644 over 45 RC. So combining like terms, EI delta B prime equals 64.8 RB plus 164 over 3 R sub C. Then EI delta C prime equals EI partial of U with respect to RC equals 0. So we use the same first on the matter in the second because of partial derivative with respect to C this time. So this is the first equation, 64.8 RB plus 164 over 3 RC equals deflection at B when the supports are removed, 8094. This is the same as before. So EI delta C prime equals integral from EI partial of U with respect to RC equals integral of negative 0.6 RB plus RC over 3x. The differential this time is x over 3. Negative x over 3. Negative x over 3 dx. 0 to 6. Plus copy this. Integral 0 to 2 of negative quantity 0.6 RB plus RC over 3 times 6 plus x plus RBx. Derivative with respect to RC is negative 6 plus x over 3 dx. Plus integral 0 to 2 of negative quantity 0.4 RB plus 2/3 of 3 RC times x. Derivative with respect to RC is negative 2/3 x dx. Plus integral 0 to 3 of negative quantity 0.4 RB plus 2/3 RC, 2 plus x. Then negative 2/3 of 2 plus x would be the differential dx. And finally here, integral 0 to 2 of negative quantity 0.4 RB plus 2/3 RC, those 5 plus x plus RCx. Derivative with respect to RC is negative 5 plus x over 3 plus x. Negative 2/3 of 5 plus x plus x. So again, evaluate the integral separately for RB and RC. This first integral gives us 72 over 5 plus 8 RC. The second integral gives us 668 over 45 RB plus 296 over 27 RC. The third integral is 32 over 45 RB plus 32 over 27 RC. This integral is 52 over 5 RB plus 52 over 3 RC. And lastly, in this integral, we have 644 over 45 RB plus 488 over 27 RC. So combining like terms, EI delta C prime equals 164 over 3 RB plus 500 over 9 R sub C. So this is equated to 6506, the deflection at C. So 164 over 3 RB plus 500 over 9 RC equals 6506, equation B. These are the same equations as before, so same answers as before. RB 153.795, RC negative 34.148, RA by statics 73.954, and RD by statics also 22.48 kilonewtons. Lastly, by the method of least torque, this is the more direct method other than removing the support. So we incorporate the redundants RB and R sub C in our equations. So these are our redundants, and RA can be expressed in terms of RB and R sub C by summing up moment about D. So there is same sectioning. So R sub A times 15, summation moment D equals 0, plus RB times 9, plus RC times 5, plus 90 equals 30 times 6 times 12, plus 36 times 7. So RA is equal to negative 0.6 RB, then negative 1/3 of R sub C. plus 154.8 because it is directed upward. Then R sub D times 15 plus RB times 6 plus RC times 10 equals 90 plus 30 times 6 times 3 plus 36 times 8. So R sub D is negative 0.4 of R sub B, negative 2/3 of R sub C plus 61.2. So because this is method of least work, parcel of U with respect to the redundant equals 0 because there's no deflection at B. And then delta C is partial of U with respect to RC, and we equate it to 0 because the deflection at C is 0 also. So EI delta B is EI partial of U with respect to RB equals 0 equals integral in this section RA is negative quantity 0.6 RB minus RC over 3 plus 154.8 times X minus 30 times X times 6 over 2 or 15x squared. Then the derivative of this moment equation with respect to RB is negative 0.6x dx. Then on the next section, plus integral 0 to 2 of negative 0.6 RB minus RC over 3 plus 154.8 times quantity 6 plus X plus RB times X minus 180 times 3 plus X and plus RB times X. Derivative of this equation with respect to RB is negative 0.6 of 6 plus X plus X. Plus next in this section, integral from 0 to 2 of quantity negative 0.4 RB minus 2/3 RC plus 61.2 times X, and derivative with respect to RB is negative 0.4 of X dx. Then in this section, plus integral of negative quantity 0.4 RB minus 2/3 RC plus 61.2 times 2 plus X minus 90. Derivative with respect to RB, negative 0.4 of 2 plus X dx. Then in this last section here, integral 0 to 2 of quantity negative 0.4 RB minus 2/3 RC plus 61.2 times 5 plus X minus 90 plus R sub C times X. Then derivative with respect to RB, negative 0.4 times 5 plus X dx. So integrating, we have for RB, we have for RC, and for the constant. So evaluate separately. For RB, for example, negative 0.6 of X times negative 0.6 of X dx, 0 to 6. And for RC, negative 1/3 of X times negative 0.6x dx. For the constant, integral 0 to 6 of 154.8x minus 15x squared times negative 0.6x dx. That's only an example, then do it for the remaining integrals. And for the first integral, the result is 648 over 25 RB plus 72 over 5 RC minus 3771.36. For the second integral, 1544 over 75 RB plus 668 over 45 RC minus 2333.76. For this third integral, 32 over 75 RB plus 32 over 45 RC minus 65.28. For this fourth integral, 156 over 25 RB plus 52 over 5 RC minus 576.72. And in the last integral, 872 over 75 RB plus 644 over 45 RC minus 1346.88. Then 0 equals these sums, or formulate the first equation, which is the same as equation A as before. Then EI delta C equals EI partial of U with respect to RB equals 0. So we copy except for the differential. So copy this, then differential with respect to RC is negative x over 3 dx. And plus this integral and the partial derivative with respect to RC is negative 6 plus x over 3 dx here. Negative 6 plus x over 3 dx. Then next, copy this integral 0 to 2 negative 0.4 RB minus 2/3 RC plus 61.2 times x with respect to RC negative 2/3 of x dx. Plus this integral, then replace this by negative 2/3 of 2 plus x dx. And then copy this integral, then replace this by negative 2/3 of 5 plus x. So copy, then here negative 2/3 of 5 plus x derivative. So evaluating separately for RB and RC and the constant, the value of this first integral is 72 over 5 RB plus 8 RC minus 2095.2. For this next integral, 668 over 45 RB plus 296 over 27 minus 1691.2. For this third, 32 over 45 RB plus 32 over 27 minus 108.8. For this fourth, 52 over 5 RB plus 52 over 3 RC minus 961.2. Then for this is 644 RB over 45 plus 488 over 27 RC minus 1649.6. So adding this equate to 0, then this will be the formulated equations, which is similar to equation B as before. So solving this equation simultaneously, RB, R sub C, R sub D, R sub A, then R sub D. So it's are the same values as before, and I hope that you were able to follow the solutions. Be patient because these are the ideas in computing for the deflections for indeterminate beams. Although we can solve this shortly by other methods in the future, by three-moment equations, loop deflections, and moment distribution. So these are just the ideas in order for you to master the basic methods, and of course with the introduction of the method of least work.